also get a red or a green marble, because that picking from this bag doesn't affect the other bag. And then finally, when I pick from my third bag, I can get a red or a purple marble, or I could also get a red or a purple marble, and as a purple. And I can also get a red or a purple marble, and I made some of these too big. And finally, I've got a red or a purple marble. Okay. Now, these aren't all equally as likely, but those are what my possible events was. At any crossroad, any place, I can make a decision or make a decision. I pick something, something happens, I end up here. I pick something, something happens, I end up here. I pick something, something happens, I end up here. And at the end of each one of these, I have kind of each variation of what's called my sample space. Sample space are all the possible things that could happen. So at the end of this one, I've actually got red, red, red is what I might have picked. So that's one member of my sample space, red, red, red. At the end of this one, red, red, purple. And you might want to pause it here for a second, see if you can't finish listing out the sample space on your own. So as we finish listing these, we've got red, green, red. We've got red, green, purple. We've got white, red, red. We have white, red, purple. We have white, green, red. And we have white, green, purple. So those are all elements in my sample space, which I'm going to finish listing out down here. Hopefully I won't make any mistakes. And white, red, red, white, red, purple, white, green, red, and white, green, purple. So those are all the possible outcomes. They are all not necessarily equally likely. And in fact, we might want to pause it here for a minute and talk about, are any of these outcomes more likely than the other? In the next event, the likelihood of picking 2 red marbles. So this is an event. An event is something that you want to occur. And the first thing I think of is, does that mean exactly 2 red marbles, or does it mean at least 2 red marbles? And that's important because it's actually a different outcome. So decide which one we mean. I'm going to be less restrictive and say this means at least 2 red marbles. So in that case, the outcomes which make up the event are all the members of the sample space, which could possibly mean success for that. So if I got red, 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 that would count. If I got red, red, purple, that would count. If I got white, red, red, that would count. I skipped over one. Right, green, red, green, red. And I think that's it. So 4 of those outcomes would be possible. And notice if I said exactly 2 red, maybe this one doesn't count. And once again, this is not necessarily 4 out of 8 as far as our probability goes, because some of these are more likely outcomes than others. And then you can make up another event and list the outcomes. I'll let you do that as a class. I'm going to move on, try to keep this relatively short. And so let me get my notes here. The next part, we're supposed to do an area model here. And sorry, this kind of bled through, so maybe you can kind of see some of that stuff from the other side. An area model is just, once again, a different way for me to list out the outcomes in the same way that I did the tree model. And so spinner 1, the possibilities are red, yellow, blue, and green. Once again, sorry about my scrawl, broken hand. So red is a possibility, yellow is a possibility, blue is a possibility, and green is a possibility. Ideally, these are all kind of equally spaced because the possibilities over here are equally spaced. So maybe red should be a little shorter there. And then my spinner over here, my possibilities are 1, 2, 3, 4, and 5. And since these, if these are all equally spaced and these are equally spaced, the reason this is called an area model is the area of any one of these things compared to the overall area somewhat describes our likelihood of things happening. But for right now, we're just talking about sample spaces. So Our sample space are all of these possibilities: red 1, yellow 1, blue 1, green 1, red 2, yellow 2, everything in here. Each one of these 20 things are members of our sample space. Sample space is anything that can happen. And then one event is spinning a color and an even number. Now, a color, we're obviously going to spin a color, so I'm assuming they mean a specific color. So let's say they meant yellow, since they have yellow highlighted there. So the outcomes for this event would be yellow 2 and yellow 4. That's the outcome. And that doesn't mean that's what will happen. Those are the two possible things if I'm asking about what the probability of yellow and even. So this P notation is very common, just stands for probability, and usually within the parentheses we list the event that we're talking about, and there's a whole bunch of ways we can talk about that. Which gets into the next part. Going back to our bag problem. If you pick from bag 1, the probability of finding a red marble. The way we find the probability, I'll let someone answer that first. But basically the probability is the size of the sample space. So the number of items in the sample space. That is all over or under the actual items in the event, or what may be sometimes called the event space. And this sample space is always bigger. Event is what's called a subset. So this will always be some fraction, and the most it could ever be is 1. So in this case, I'm going to flip back. We had how many marbles? 5 and 4. So we had 5 red marbles out of a total of 9 marbles. We had 4 white ones. So 5/9 is one way to list the answer. We could also do that as a fraction, so as a percentage. So 5 divided by 9 is 0.5 repeating, or 0.55 roughly. I'll put 0.555. Or as a percentage, it's 55.5%. Those are all proper ways to list a probability. As a fraction, as a decimal less than 1, or 1 or less, could be 1. Or as a percentage, which just means you move that over 2, and you can talk about it as a percentage. And oftentimes you'll also hear people say that the odds of something happening is like 5 out of 9, or something like that. That's how many chances you have out of how many total possibilities. So those are all different ways that people will talk about it. So as a class, I'll let you go through the rest of those. You can talk about it. And let's flip to the next page. The next page says the probability of finding a quadrilateral out of this list of things we got here. So first of all, we need to, in order to do probability, we need to know the size of the sample space. This is all about counting. So we need to find the size of the sample space. And so if I look in this bag, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, they gave me a weird thing. It would be so much easier if there's 20, because I can do percentages out of 20 much easier. But there's 19 as far as I can tell there. And the probability of picking a quadrilateral, probably the easiest way is to count the things that aren't quadrilaterals here. So I've got those 2 hexagons, and I think I've got just 2 triangles. This thing down here kind of looks like a triangle, but it's I think it's a parallelogram. Okay, so my total possible things in the sample space, there are 19 things I could pick, and then of those, 15 of those are quadrilaterals. And then so once again, I'm going to get my calculator out to figure out what that is. The other way I could list that, which is more common, is 15 divided by 19 gives me 0.789. So I could say 0.789. There's a 0.789 chance of me pulling a quadrilateral, or I can also say that's a 78.2% 0.9% chance of me pulling a quadrilateral, the first thing I pull out of the bag. Complement event, choosing. So a complement of the event, which it says up here, is all the outcomes that are not in the event. Okay? So the outcomes that are not in the event are, in this case, those 4 that we didn't count. So the complement of that, the probability of not, and I'm going to write it this way, probability of not a parallelogram, of quadrilateral, okay, of not a quadrilateral, that's supposed to be a quadrilateral. And we often use that little bent thing to mean not, it depends. But the probability of not that, which basically means the probability of triangles and hexagons, is, drumroll, 4 out of 19, which once again in my calculator I can do that and I get 21.1 roughly, so 0.211 rounded, or 21.1%. Those are all 3 good ways to list the probability. And I'll let you look at the remaining part of that as a class, because I want to make sure I don't make this too long. And I just want to look at this last part here. I'll let you do, these are kind of discussion questions. The last part here is